Hello and welcome. My name is Bosco Kane and my student ID is 1006214655. And today I'm gonna talk about sand rendering and Journey. So Journey is a multiplayer PlayStation Network game, and the theme is basically try to recreate the feeling of out in the nature and have connection with other players. So in this image we can see the character and obviously the sand. So for this character it's basically 100 pixels per meter, and there's 400 sand grain per pixel, and this is the final rendering as we can see, and it's called shipping. And there are 6 things we need to have in order to generate this image here. And the first thing, we have sharp MIPS, and basically we have a detailed normal map with just noise on it, and by using a histogram, and we test it and show which direction normals are pointing to, and if the normals are pointing upwards, meaning we will get less grainy texture. To get a grainy normal map, we just have to multiply normals by 2, so the normals are pointing to equal directions. So second thing, we have glitter specular. So this effect, basically we use a specular shader reflecting on a noisy normal map, and the sparkles would move around along with the player's camera. And with the development of this, they actually went from n.h, which is a physical based specular equation, to an n.view, a basic view dependent, for smoother graphics and easier to control how much glitter to generate in the scenes. And third thing, we have anisotropic masking, and there are 16 tabs of filtering on all sand textures, and this is actually the maximum PlayStation 3 allows. And non-formally sized pixel will just lead to too much graininess, and so it won't look realistic. And by using color intensity texture, and based on the distance from camera, it will give some predictable values of the color in the scenes, and along with spots where the filter is failing, we'll get this masking effects. And so in this masking effects, they're showing white spots and black spots. And white areas meaning it is safe to render full filtering, and black areas are where the filters cannot keep up with the rendering. And next we have ocean specular. And suppose there's a light beam underneath the character, as we can see in this image even. And how we do it is use the same specular shader, which acts like how the sun's reflecting on the water. But this method is not realistic, but it works well in the game. And then we have diffuse contrast, and here we have a diffuse shader used in the game, which is a higher contrast than what we normally use. And rendering this effect, they use this method called Ornaire, and it's a physical based shader for diffuse lighting. So they apply this shader for the character's clothing, like the cloth, but this method is generally expensive, and also the developer mentioned that he was inspired to use this reverse random shuffle and to try out random things until they actually work. And so here we have the final shader. It's fairly simple. And last we have this detail height maps, and this effect is used to create fine-grained geometric detail, and each level has a low resolution 256 by 512 height maps to represent the dunce. And these height maps are streaming into vertex buffer using B-spline filtering for smooth graphics. And the developer had mentioned that second derivative continuous, allowing the use of second derivatives for ambient occlusion. And last thing they did was adding high resolution tiling height maps on top for some shallow or steep sand.